Hello and welcome back. My name is Chris, and today we are going to continue our work on our YoshiStat, which is a smart thermostat based on a Raspberry Pi Zero. I'll show you the hardware here. This is the YoshiPi. You can see here it's a 1B, but basically it is a Raspberry Pi Zero on a carrier board that has some things like a display, a microbus connector. We've got a temperature microbus clickboard here, so this brings in our temperature of the ambient room space. And then it also has some relays down underneath here that we're going to use the output here to control both our forced air furnace and our air conditioning system. So this is the hardware we're targeting, but because doing development on direct hardware is a little bit more challenging, we're also running a desktop app. So we're writing all of this in C#. We've got 3 different projects. Let me collapse these down. I have a core project, a desktop, and then the YoshiPi. So the desktop and YoshiPi are implementations that have code specific for the platform that we're targeting. So this has hardware specific to the YoshiPi, this classes and implementations specific to the desktop, but most of the code is here in the core. So anything that is common across both platforms is ending up in here. This is, I think, episode 6, somewhere around there. Been doing this for well over a month now. We have a lot of the capabilities or functionalities implemented that we're going to need. We have, obviously the display showing the current temperature, but we also have relay control done. So we have the opening and closing of the relays on the hardware. We also have simulated relays on the desktop. We have our control algorithm that looks at the inputs. So we obviously also have the input from either a temperature sensor or from the simulated temperature sensor working. I believe it was last week we implemented on the desktop some capabilities where we can use the up and down arrow keys to change the simulated room temperature so that we could work with the control algorithm. So we kind of have all of the basics that we need for a thermostat working. Really, the next thing I wanted to do is add some of the settings pieces that are necessary for this thing to actually be useful. The obvious big setting is the set point. The set point is the target temperature that you want the space to be. You can't just have a target temperature, though, because if you have only a target temperature and you try to drive to it, let's say we're heating, as soon as we go past it, we shut off, and then as soon as it comes back below it, it would turn back on, and you'll get it doing what's called a short cycle. It'll be turning on and off very quickly in succession. You don't want that to happen. So we've got a region around that temperature that it drives through. So it turns on, keeps driving, and then turns off at a higher temperature. That region is called the dead band. We've got a dead band for heating and cooling, and we're using a single set point for heating and cooling. If you want to know exactly how we implemented that, I will put a link up in the corner that is, I believe, last week's, where we talked about the control algorithm. This week, we need the user to be able to set that. Right now, the temperature that we're driving to, I think, is here in main controller. It's somewhere around here. At any rate, it is hard-coded. So what we want to do is we want to have a settings service where that temperature is stored, and we want a user interface, say an up and down button, something along those lines, that allow the user to adjust what that temperature is. Today, that's what we're going to do, is we're going to add a user interface screen. My hope is to get somebody else to do some design work. I am not very good at design. I can tell you what's good design and what isn't by looking at it, but I'm not very good at building those designs. So right now, in this, we're not going to worry about the design of the screens. I'm just going to drop a couple of buttons on. I'll probably create a second screen 4 settings, maybe 2. We can discuss that when we get to that breakdown. But we're going to have some user interface that we're going to design today for, let's say, the adjustment of the set point, and maybe we can add one more user settings screen and control a couple of things like, let's say, the units, so whether or not we're showing Fahrenheit or Celsius, and maybe what we want the clock to be. Do we want it to be in a 12-hour clock or a 24-hour clock? We've got lots of potential that we could do, so let's at least run the plumbing for those user settings. So we need a UI to handle all of those. We're going to have a service that handles the getting and setting of those, and we might even provide some sort of a storage mechanism so that if you lose power or shut off the thermostat, when it comes back up, it can reread those settings and set everything back up for you. So that is the plan for today. Let's go get to it. So the first thing I want to do is give myself just a quick refresher on what we have working. So let's go over to the desktop app. I'm going to guess that we're probably not going to use the hardware much at all today. If we do, it'll be just for validation at the very end. I'm hoping to get most of this development done right here on the desktop. It's much faster, much easier. I don't have to worry about deploying anything. I don't have to worry about connecting up a remote debugger. Everything's just running locally here. And that is why I create this desktop platform. So let's just run this desktop platform. All right, so we get a console and we have the thermostat display. The other thing to know is this does have a splash screen when it powers up. Not that it's terribly important, but since it powers up on my other monitor, you rarely see that. So we have, looks like a humidity value here. Now it is important to note, and maybe that's something that we can put in to the options here. If we look back at the bench, right now I'm using this Thermo 13 click board from Microelectronica. This board, it is a BH1900 NUX part. So this little chip out here at the end, and that's bringing in our temperature. I think it's a fairly high resolution temperature, but it does not have humidity. So I don't currently have any way to get humidity on this. Now there is another clickboard. I think it's like maybe a Thermo 15, something like that. At any rate, there is another board that plugs right in like this that has both temperature and humidity. So we could, as an option, as we're looking at these options, add in something that allows us to change this board and have something that has temperature and humidity. So if we go back to the screen here, we've got this humidity here. We would want that to be visible or not visible based on what sensor we have. But if that's something that is of interest, we can maybe go in and put that in. The reality is this Thermo 13, the one that I have plugged into the hardware, the reason that I'm using it is because I had it on hand. That's the only reason. It's just, that's what I had, so that's what I plugged in. If I had had the Thermo 15, that's probably what I would have ended up with as well. Down here, we have a time. It always says 11:11, so my guess is that this is not plumbed through to anything. It is just a hard-coded text, so we can do that. It's interesting, I guess, point. If we come back to here, I've got a connector here for a DS3231, which is a battery-backed real-time clock. So we will probably implement that. If we want to have an accurate time on this Raspberry Pi, we have to do one of two things. We can either use a real-time clock like this, or we can use a network connection, connect out to the network, and use the network time server. Now, it's interesting to think about. If we go with network time, then again back here, you can see that this Raspberry Pi, the Pi Zero, this is a 02W, it has wireless interface, so it's got Wi-Fi, but it does not have Ethernet. And so we would then have to have some sort of a user interface to allow the user to put in Wi-Fi credentials. We could do that directly here, but we're not going to have a keyboard. So if you've ever used something that didn't have a keyboard for entering text, like a Wi-Fi password and the SSID, that can be not so fun. So we can think about that. That would be building a keyboard UI and a bunch of those kinds of things. Another option is this Pi Zero, I think, has Bluetooth. So maybe we could implement a Bluetooth listener, some sort of a Bluetooth server, have it come up. A few different ways we can look at. Definitely not going to attack that problem today, but it is something that we can start thinking about. Temperature, time. I think what I'll do, again, I am not worried about the design and layout, the UX of this application. Maybe for simplicity, let's just go, if you touch the label, that will go to a screen that will have adjustment for the set point, and that would give us our set point, probably an up and down arrow that allows us to adjust, maybe an apply. That way we can apply or cancel. And then maybe another button down here for going over to settings. The UI on this, all of the layout is done with a thing called micro layout that I basically built. It is designed sort of like WPF or Xamarin Forms or something like that. So you've got some controls that go into a layout, and that layout goes onto a screen. It only supports about a half a dozen controls because really that's all you need to do a large amount of UI. And because, well, I've got limited resources of time, and so I only put in things generally as I need them. So as I need a control, I might add it in. That's open source. Again, link down in the description down below on where all of that is, but that's part of the Meadow Foundation library. First, let's look at the display service. So let's just adjust that UI. I know that I'm going to need to get into a settings service and potentially a storage service. Don't know if those are one and the same at this point. My guess is that they're different. Another thing that I want to do in the future is add a graph, a historical graph of space temperature into this so that you can look at, maybe what the last hour was or the last day, or maybe even selectable by the user, but a graph of temperature versus time. So we want to be able to store those temperature versus times off. Those are not a setting. So now I have settings that I want to store and I have data that I want to store. So that indicates to me that I'm going to need some sort of a storage service that I can tell it to save things and then I can retrieve back from. Again, this is just kind of how I go through problems like this. I have not designed any of this on paper. This is all, as I'm thinking about it, we're developing this application. So that's why sometimes it's a little disjointed. So the display service might be worth noting that this service is common to both platforms. So we have one code base that is doing both the display that we see here, and if we run this application on the YoshiPi, the same exact code is what is rendering the display down on that hardware. That is done through micro layout, which sits on top of a library called micrographics, also open source, which sits on top of the display drivers for those two different displays, which are also open source out in Meadow Foundation. And again, links to all of this stuff down below. If we talk about the micro layout just briefly, we have a thing called a display screen. So the screen is kind of the abstraction of the physical screen that we're working with. In this case, it is this window that is our screen, and on the device it is that hardware, I think ILI 9341. So that has our screen, and then on top of that screen we can put controls, but we can also put a layout. So a layout is really a collection of controls. And so right now we have a couple of layouts defined, one for the splash screen, and that gets shown, and then one for the home layout that shows that humidity, temperature, and time. The nice thing about using a layout is I can just show and hide the layout, and that shows or hides all of the controls on the layout. It allows you to change screens very easily without having to adjust a whole bunch of controls or move controls or things like that. So I like to just build a layout for each screen and then just show and hide the layouts. We have the splash and home, but we know that we're going to need two more layouts, right? We want one for adjusting our set point and one for, let's just call it user settings for right now, or application settings maybe. It's the one that we're going to have our temperature and our time, our clock setting, 12 or 24 hour. So let's just create a couple of those, or define those to begin with. There are methods in here for generating each one of these layouts as a screen. So at the beginning, we have a display screen, and it adds the splash screen and the home layout. So those two layouts, we're going to add the other two layouts, but we need to create them first. So it's right after it shows the calibrations. If it's required, it loads these screens. Now we're going to have a couple more. So I actually am going to create a wrapper method around that. And then just take one of these as an example. It returns void and takes no parameters. So we're going to go with the same for our other two layouts. And I'll keep the same nomenclature that's in here. So some of this screen layout was done by Jorge, another developer who's working on this project. He's the one that I'm hoping will do all the design work, and he's doing some of the UI layout. So I'm going to keep with the nomenclature he's been using, calling them screens. So we'll have a set point screen and a load settings screen. Then we know after we load them, we're also going to have show for each of those. Might as well just do those right now. Okay, so those are probably all of the methods that we're going to need, at least from a gross layout point anyway. So our home screen, now we know we wanted to add a couple of things here. First, we wanted a button that we could click that will take us to the app settings. So let's just put that in right now. And I'm going to be a little more explicit with its name. We'll call it the Show App Settings button. And it is going onto the home screen, which is here. So I'm just going to come down to near the bottom, and we'll create it here. And then this button, where will it live? Let's put it into the lower left of the screen. We're going to put at 5, so not right against the edge. We'll put a little bit of a border there. The top, let's make this button 30 in height. So we want a bottom margin, so 35. So we'll actually make this the home layout. So the container that this button is going in, we're going to make it the height of that minus the button height, 30 minus the margin, so 35. We'll just make it a width of 50, and that's all we need here, but let's set some text on it as well. If I do that, it's probably going to be way wider than this. Now remember, this screen is 320 across, so that's kind of how I look at this. So in my head, 320 across, this is a third of the screen. That's probably about right. Again, once we run it, we can adjust these settings, but for now, it gives us something to at least look at. We're missing one parameter, the height. So we'll make it 30 high. There we go. All right, so that gives us our button. Now we're going to add a button click handler for this. All right, so we've added our handler, which is here. And right now, really all we want to do, we're just going to show the app settings. Now that is an async method, but we don't need to really wait for it once we click it. So we'll just use the discard for that. So when we click that button, it will call the Show App Settings screen, which right now doesn't do anything. So now let's build that app settings screen. So it's a new absolute layout. The only layouts that micro layout currently supports are absolute. Ideally, it would support something like a stack layout. I just have not had time to do that, so everything is an absolute layout, and I'm just going to cheat and borrow this from the home layout. And so the layout is going to be the screen width and height, and it's not going to be visible. I'm going to put a label at the top. We'll just call it settings. Now here, I'll just make it basically full screen width, or the layout width, and then center it. Now here I can, I've got an underscore indicating it's a field, but we can just do that because I'm never going to adjust it. So I'll just put it here as a local variable, and then I will add this label to the controls for the app settings layout. And let's go up to that layout. I want to fix the capitalization error that I've got going there. And we need to load that layout. So it looks like we currently load them at the bottom of each one of the load screen methods. So we've got to come down here and we'll add that to the screen. Okay, so we have created the layout. We've added a single label to it and then added that layout to the screen. When we add it, it is not visible. So it's, back behind, or we don't have Z orders. So it's not visible. So what we want to do is we want to, in the show, the app settings screen, we want this to become visible and all of the others to become hidden. And we'll adjust these other ones to make sure that they are not shown. All right, so in theory, I should be able to run this app. It should give us a button on the home screen that we can click to go over to the settings screen. Now, of course, there won't be any way to come back, but that's fine. I just want to verify that this is doing what we're thinking that it should be doing. Basically make sure that the click handlers are getting wired up and the layout is getting displayed. I just want to make sure that that piece is working, and then I can work on adding things into it. Ah, yes. The Setpoint screen. We'll just remove that not implemented for now. All right. Here's our app. And we don't have our button. It should be right down here. And if I click, it is not happening. And this is why I wanted to run this first. And I did it again. I forgot to add the button to the home layout. I often forget to add the control to its container. So let's try it again. There we go. So you can see it. It's quite ugly, but it's at least here, right? So I can click it. Takes us to our settings. So that's doing what we want it to do. So for current use, just to make sure that it's all working, I think that's good enough. Let's go over to this settings screen and let's put two buttons on here. One for apply, one for cancel. Both of them will just take us back to the home screen. But will plumb through at least those clicks and the navigation. So basically what we want to do is we want to work on the navigation stack. I don't have a navigation stack per se here because I don't think this app is going to be that complex. So I'm not worried about having some sort of a, move forward, move back in a stack. We're just specifically saying go to a specific window. We might need a stack if we get complex enough, but I don't know that this app will ever be quite that complex. All right, so let's go back down to this screen, and we're going to add a couple of buttons. Now, because we are starting to get a little bit long, we're at 300 lines, which is a lot for a single file to me. I might actually split this out into multiple files just to make it easier to navigate around, right? Because what we have is we've got these field level controls. So these controls here all are on the home screen. Then I'm going to have a block of controls that are on the set point adjustment screen. I'm going to have a block of controls that are on the screen for these app settings. It's just going to start to become a mess. So if I move these into separate files, it'll just be a partial class. So it's one class, but split across multiple files. It will just help me to work on this a little bit. All right, so that puts all of the app settings pieces over here. And while I'm doing this, I might as well create the file for the set point stuff, because I can kind of copy what's going on here. So we've at least created the file for it for when we get back to it. So let's go back to the app settings. Now we've got all of our stuff in this one file, so it's going to be a little bit easier. Don't have to do a bunch of scrolling around to find the pieces that we're working on. All right, so let's add the two buttons, apply and cancel. These buttons I want to, basically I'm going to put them down at the bottom. I'll have the cancel on the left, the apply on the right, and I really want it to be, for now, again, not doing layout, but I'm just going to put them in the exact same spot as the button that got us here. So I'm just going to come over to here and copy it off the home screen. So we'll put our cancel button basically in the exact same spot as where this settings button is. Now I want to make sure I put it relative to the, not the home layout, but the app settings layout. And this one will be cancel. And then we'll do the apply. And the apply, the only difference here is its left will be at the right side minus, we're going to go 105 because the button itself is 100, and then we're trying to put in that 5 pixel margin. I think that will give us what we need. We need to add these to the layout. So that should put them onto the layout. Let's add in click handlers. Now the click handlers for now are going to do the exact same thing because we don't have anything to sync the events for applying. So we're just going to go back to the home screen. That'll wire up a couple of handlers, and both of them, we're just going to show the, it's called the data screen. I'm going to change the name of that because I really don't like it. So let's run this. In theory, this should bring up the app. We have our settings button that takes us over to the settings window, which has two buttons, cancel and apply. They should both take us back to the home, which they do. So now in our app, we have multiple screens, and we have navigation between those screens. Before I go in and worry about implementing some actual settings on that settings screen, let's do a similar treatment for the set point. So we know that if we click here, and I'm pressing the button right now, if I click here, we know that we want to go to a set point screen. So let's go take a look and see if this even has a click method. If it does not, then we have to either implement click on the label or maybe hook the direct click action of the touch screen. See if we're lucky. Current temp label dot. It does not have a click. I'd really like it to have a click though, so I'm going to go add it. Nicely, we have project references here, and being open source, we can just go adjust this micro layout. And it is the label control that we want to adjust. Now the question is, how do we go about adding clickability into this? Well, we know that the button has clickability, and it gets it by inheriting from clickable control. Is clickable control themed? It is. So we can just go to this, add this to our label, and I wonder if that's enough to get us click just by adding that base class. I'm not even going to go look at how all of that works. I'm going to see if just adding that clickable control base gets us what we want on this. So let's try that. It adds it here, which is what we want. I'm just going to put a breakpoint here. Let's run this app. Let's see if clicking this gets us there. Look at that. Gotta love adding capabilities with one line of code. Okay, so that will be perfect. Here we will want to show the set point screen. Let's go over to here, show set point screen. And I'm going to just steal some of the stuff that we did before. Now I'm going to set the set point layout to visible true here, but that means because of the way we have all of our other stuff, I need to go make sure all of the other layouts are not visible. So I'm going to come back and put it here. So now we just need to create our layout and add some stuff to it. And the first thing I want to do is just like we did with the app settings. I'm just going to throw a label up there to make sure our navigation to and from all of that works. And in fact, for this, I think we're going to have an apply and cancel as well. So let's just basically steal almost all of the code that we did in the settings. And we're going to move those or copy those over into our set point. All right, so I think that'll do it. Basically what I did was I just copied all of the control creation and layout stuff that we just did for app settings and put it into the set point. Changed the title here to set point instead of settings. But now we should get the same behavior when we click on the temperature on that home screen. So we should be able to click the button for settings, go to the settings screen, click the temperature, and it'll go to the set point screen. So let's run that and make sure that is doing what we are thinking. So our app comes up, settings, goes to settings, we can cancel, settings, we can apply. If we click the temp, it goes to set point, we can cancel. Oh, there we go. We have to implement these. Home screen. And again, we don't have any difference between apply and cancel right now because we don't have it actually doing any of that logic. Again, settings we know works. Goes to our set point, apply, set point, cancel. All right, so all of that works. Next, let's work on the set point screen. We're going to put the temperature. So when we click this, it'll come over here. We're going to show the temperature. We're just going to show with no decimal places the set point here, and then we're going to allow you to click apply. So let's go do the layout on that. The current set point label, I'd like it to be similar to the home screen. So I'm just going to swipe that. That way I don't have to worry about sizing, locating, all of that. Right now I'm not going to worry about units. We're only going to be dealing in Fahrenheit. We talked about changing units with a setting, but since I haven't plumbed that setting in, I'm not going to worry about it right now. So we're going to initialize this with the previous set point, Fahrenheit, with 0 decimal places. So that will initialize that. And then let's create our increment and our decrement buttons and hook up the handlers for those. Rather than measuring this out, I'm just going to drop them on the screen and then move them after running it. I know they're going to be to the right of the midpoint. Actually, let's just put them all the way to the edge of the screen and then come back 35. We'll just see how that looks. All right, now this should have an error because nothing is calling this with the previous set point. And I guess what we'll have is we're going to have a current set point, and then we're going to have another one that is our, what would we call it? It's a temporary set point. It's the one that we're working on. We're going to increment or decrement. I don't want it to actually apply until we set it to some value. Because we might want to cancel it. I'll just call it the temporary set point because right now my brain can't think of a better name for it. Here, we're going to want to show it with the current set point. And we're going to bring that in. Our temporary will start at the current. We're going to need to adjust the label and things like that. But right now, let's just try to get this screen to come up with what we want. All right, so when the label is clicked, that's when this is going to happen. So right here is where we need to pull in that set point. I think we've got to go get that from a service. So we're going to need to go to the configuration service or the settings service, however we want to go with. But we need to have that setting pulled here. The main controller also needs to get notified when it gets changed. There's a bunch of things like that. Probably does not need to be an interface because I don't think we're going to have multiple implementations, but I'm going to start with one anyway. And I think it's going to be the same functionality regardless of platform. So we're just going to put it in core. Then our main controller seems to be where we create all of these services. So we're just going to go into the main controller and we're going to do it right here when we initialize it. So let's just build the setting service here. We know we need it before the display, so we'll create it right away. And then we're going to pass it into the display service. The display service will take that in. Setting service, we're going to have a get and a set for the set point. Rather than a property, I'm going to use methods because my suspicion is we're going to want to save this out somewhere. It's going to actually have some logic. It's not going to be just setting or getting a field. So we'll take both of these and put them into our settings service. And for right now, we're just going to keep them in memory. I'm going to add an initialize here that we'll call from the constructor. In the future, this is where it will pull the value from storage somehow. But for now, we're just going to set it to an initial value. So we'll set it to 66. Now back in our main controller, our set point here is settings, get current set point. So we'll initialize it in there instead of setting it here. And in fact, we probably want to do this changeover time and deadband in that setting service as well. But let's do one thing at a time. Back to our display service. It should be getting that from the settings. So we know that we have all the way down here in our settings. When we load, we also need to update that label, right? Anytime we say show it, we want to adjust the current set point label. Set its text. Let's just run this and see how it looks. Okay, it says it's 68 and it's cooling, so that tells us that we probably are below. So we need to fix our buttons. Those are kind of ugly. It's too tall and it is not showing the values. So let's go do that. All right. Put a breakpoint here. When we click it, first, let's just set a step into that. Current set point is 66 Fahrenheit, which is what we want. Put a breakpoint here. The text of that should be this value, 66. So let's run that. Okay, so that will give us our current set point. Let's adjust those buttons while we're here. Okay, so the increment and decrement. We have the potential that we could send it all the way back to the settings service and then react to maybe an update or something like that. But I don't want to do that since we have this apply and cancel. The reason that I want to do an apply is I don't want to say move it up 1 degree and then that cascades through everything all the way to the control logic and then makes potentially the state change while we're adjusting our set points. I want the user to select their set point, say apply, and then have that cascade all the way through until it reaches the control loop and adjusts behavior. So we're going to let the user go through, select their set point, hit apply, so then it'll go through and apply to that control loop. What I had done therefore is I have this temporary set point and we're just going to be adjusting it. So on decrement, we have our temporary set point is our temporary set point. We're going to subtract 1 and then convert it back. And this shouldn't be nullable because it can never be null. Let's just do that. And then increment's going to do the same thing, except we're going to add a degree. So we're going to subtract or add a degree. And then once we do that, we want to update the display for what our current set point label is, right? We just adjust the temporary set point, increment it or decrement it, depending on which button we click, then update the label, which will set the label text to that temporary set point. Only on apply will we actually do something. So let's just test that. In fact, I'm going to put a breakpoint right here on apply. So if we come over and run our app, comes up, the set point is currently at 66 because that's what we have it initializing to. There. So now click down and you can see it's decrementing. I can click up And if I hit cancel, it just goes back. Now, if I do this, let's say change this to 69 degrees, 70 degrees. If I hit apply, it will come in here. And now our temporary set point, if we look at that, temporary set point is at 70. So our temporary set point needs to get pushed back to the set point service at this point. So settings, set current set point to this temporary value. And that should send that through to the setting service. Now, if we set it here, we need other things to be able to react to it, right? So let's add an event. If the value coming in is equal to our current set point, we're just going to ignore it. Otherwise, we're going to set it and raise the event. We want that event now to be in our interface because the main controller has this setting service. And when the set point changes here, this is where we need to worry about our control loop. So it is looking at the set point. Okay, right? So this is looking at this stored set point. I don't want anybody to be able to set that. But in our handler, wherever that got added, here, that will set the set point property in this controller. And then if we look at our control loop, it looks at the current temperature and then compares it against that set point property. So, in theory, should be able to run this. It's going to initialize to that 66 degree set point, which is going to drive to cooling. I can click on that. In fact, let's cancel. Let's come back out. Let's change. That's fine. We'll leave it here. I still can move the temperature of the space with my arrow keys on my keyboard on the desktop. But let's say it's 66. I'm going to click this, and I'm going to set our set point to 70. If I apply that, it has now stopped this. So it's quit cooling, but it has not gone to heating. And the reason it hasn't gone to heating, if you recall in the control loop, is because our change over time. So I'm going to bet that our current temp is below our set point, but the last cool time will be set, right? And because it was set, it's not going to control this. So I think when I change the set point, I want to clear out both the last cool and the last heat time and reset it. So we set it to null here, but then because the set point changed down here, the last cool time got set. So we need to ignore that. There are a couple of ways to handle this. We could keep a Boolean flag that says, hey, we just changed the set point. Deal with that. Or we could set the set point and wait for the control loop to run a cycle to see if it is going to set those, and then null them out, and then it would go through and do that again. So I'm going to change this. Well, I'm going to add a field here. Control loop time. I put that here. And then when we get that set point change, I'm going to wait. I don't want to wait just a single loop time because I want to make sure everything happens. So let's just try 2 loop times. We could probably do 3 somewhere in there. Let's just wait 2 though. Let's just see if that does it. In fact, I'm going to do 3. This is in human time, right? We're going to adjust it on the thermostat. We don't necessarily expect that as soon as I hit apply, it's going to click on that heat. If it takes 2 or 3 seconds, that's fine. In fact, I think my current thermostat does that. I don't notice a change in state immediately. So let's verify that this works. Again, we're at 66 degrees for a set point. Space temperature is 68. We're driving cooling. Click this. I can adjust it. If I cancel, it does nothing. That's expected. Let's set it to 70. Apply. It shut off. Then after 3 seconds, it turns on heat, right? So we saw the cool relay close or open, and then the heat relay close. So now we are heating. Now if I click this, our set point is 70. Come back. Now let's raise the temperature of this space. And it shuts off. Now let's do something, and let's set our set point. This is going to be a problem I can see right now. So the problem that I see, let's say it's wintertime, and I have my set point at 70, and for some reason our temperature is up here. Maybe I've got like, a gas fireplace for, ambiance or whatever. I'm running some other heat source, and it's now above, so our set point is 70, but our space temperature is above. So let's say it gets up to 70, 2 degrees or something like that, right? Say it's up here, and we go, oh, I'm going to turn the set point on my thermostat down because I'm going to bed, shut off the fireplace, and turn this down to, say, 68. Now, if I apply this, it's going to turn on the air conditioner. That's not what we want. So we have an edge case that I'm going to have to deal with, have to think about. I'm not sure exactly how to solve it because, again, we have that other edge case where we don't want it to, where we're swapping from heat to cool. We don't want that to happen just because we've adjusted temperature. This is the challenge with having a single set point for a system that can do both heating and cooling. This is easily solved with a dual set point, one for heat and one for cool. The problem with that is it can be a little confusing to the user when you say, I want to heat to 68 and I want to cool to 65. That's a little confusing to users. They're like, what does that mean? These are things that you want to keep in mind if you're actually building a product for other users. How challenging is it going to be to use? A single temperature is better. Now, the way most modern thermostats, not smart thermostats, but most of the other thermostats you see, the way they handle this is they've got a switch for heat and cool, so it will only do one operation. That makes it really easy. We could add something like that onto here, so we go, it's only in heating mode or it's only in cooling mode, but I'd like it to not have to do that. I don't think you have to do that with a lot of today's smart thermostats, so I'm going to try to avoid it. We just have to think through the logic of these changeovers. So this is the one edge case that I'm going to have to put some thought into. I don't think we're going to solve it right now. We've also been streaming for about 2 hours, so I think that's probably good enough. I think we're at a good stopping point. So let's recap where we are. We have added a settings screen that we can navigate to. Right now it doesn't have any settings, but we've at least built this screen we have the cancel and apply. The idea for this screen is we can change these units here in case we want to drive off of Celsius. We also can change this clock to a 24-hour clock, maybe some additional settings. The point here is we're really trying to plumb through some navigation for the user interface. We also have a cancel and an apply button. Both of them bring you back, but they do follow different code paths. So if you go over here and the user changes some things, they can hit apply and save those. The other thing we added is we can now click this label that is our temperature, and this will go to the set point, and this allows us to adjust this set point. We can use these buttons to increment or decrement that. We can cancel that change, or we can change it, say we increment that. And that, you can see, has changed the state of our control loop, and so now we're driving heating. So our application now is actually getting close to a functional thermostat. We could, in fact, push this to the hardware. It does open and close relays, so we have enough here that this could be a functioning thermostat that you could install. It doesn't keep any of its settings, so if it lost power, you would lose things like that. So it would not be friendly. It doesn't have any scheduling, doesn't have any of the other more advanced features, if scheduling you want to consider advanced. But it doesn't have any of that. But those are the next things that we're going to start working on. So that'll do it for this week. I think that's enough features for now. I will take the code, update that, send it up to the GitHub repository. Again, link down below. At any rate, thanks for watching this week's stream.